So again, we're going to start talking about deformers. So we are going to eventually need to attach our geometry to our character's joint system. And so the skin binding method that we use to do that is a type of deformer. And what I would like to do again is just recap deformers in Maya. So we'll look at a few different deformers and ways we can use them to do things like modeling or drive animation. And then we'll look at skinning. So again, you guys, I believe, should have covered this information in the intro class. So this is just a refresher. So Deformer is a system that allows you to change the overall shape or deformation of the topology or of a geometry. And so it's going to allow us to more or less deform it. And that's all of our skinning does. When we do a skin bind to our rig, it's going to allow us to apply influences from our joints to the geometry itself. In terms of deformers, there's a couple ways you can get to them. So if we're in the modeling menu up here at the top, there is a deform menu with a lot of different options. You can also access the same menu from the rigging submenu. So if I go to modeling and switch on over to rigging, here we still have that same deform menu with all the various options. Now the other deformer we get specific to the rigging submenu is skin. So in here we have all the different skin binding and skin options. So we're going to start here with deform, and we'll look at a few different things in here. So up at the top there we have blend shape. Now this is something we'll look at a little bit later, but this is how we're going to get more complex facial expressions in our character's face. We can also use this as a way to do corrective blend shapes. So we can correct deformations. Let's say your character's when they rotate their foot up, the pant leg intersects the foot. We can actually use a corrective blend shape to automate animation so that it looks like the pant leg or the cuff actually rests on top of the foot instead of penetrating through the foot. So we'll look at that a little bit later in the semester. But that's blend shapes. Let's see. Clusters, we'll look at that. We've already looked at these a little bit before, but we'll look at these just a little bit more. It allows us to take a selection of either components or objects and cluster them together, or combine them together with a cluster that we can use to drive deformation and animation. We'll also look at a lattice deformer, so it creates a cage around our geometry or components and allows us to further modify the topology of that surface, again using a lattice cage. We'll also look at things like this list of nonlinear deformers. So there's a few things in here. We have bend, flare, sine, squash, twist, and wave. And there's a lot of useful things we can do with that in terms of modeling and animation. So we'll look at all of these here. And then if we go to the skinning, again, a lot of options in here, but the ones we'll use primarily, we'll use bind skin, and then there's also interactive bind skin. So there's two skinning methods. There used to be a rigid bind or a third option, but that's no longer used. So again, we only really rely on this bind skin option here for the most part. So let's start here in the deform menu. So I'm just going to tear. We won't tear it out. Let's make a new geometry here, and like I said before, the cluster, this allows us to select either a series of components or a series of objects and attach them to a cluster node. So in this case, let's go ahead and apply it to a selection of vertices on this sphere. So I'm going to right click and go to vertex mode, and I'm just going to grab a handful of these vertices here. And then with those vertices selected, let's go back to deform and let's apply this cluster. Now, all of these deformers, they are history based, and so if we were to delete the history, it's going to remove the influence that these deformers have over our geometry. And they also create node based history in our channel box over here. So you'll notice when I have my sphere selected, over here under inputs, I now have a cluster node with, depending on what deformer you have, you're going to have a variety of options here. So the cluster only has envelope. Envelope is something you'll come across fairly or commonly with these deformers. The envelope is just the overall influence that the particular deformer has. So when this envelope is 1, it's 100% influence. When it's 0, it's 0% influence. Now, in terms of the cluster, the way we can use this to deform our geometry, you just select the C shape there, that little node for the cluster. And then I can move this and translate it. And whatever vertices or components I had selected at the time, they will follow this node as I move it. Again, if I go into that cluster node and control its envelope, this is something I could key or animate in between. So again, when this is at 0, there's no influence. And then at 1, it's 100% influence, and it's going to go to wherever that cluster node it has been translated to. Now the cluster, it also has a paint weights, kind of similar to what we have with skinning. So if I were to select our geometry here that the cluster is applied to, right click and go down to paint. In here we should have cluster weights. So this is that first cluster that I applied. If I go ahead and select this, it's going to go into the paint map mode where we can paint the influence that this cluster has. Everything that's white is getting 100% influence from our deformer. Anything that's black is getting 0% influence. You'll notice we can paint directly on this now. So once we're in this paint mode, I have a brush. Do keep in mind the brush keyboard shortcuts are pretty universal between Maya, Mudbox, the soft select tool, the sculpt tool. It really doesn't matter. If it's a brush, the keyboard shortcuts are pretty universal. So in this case, if you want to, let's say, change the radius of your brush, I'm going to hold the B key. It's B like Bravo. And then I'm going to left click and drag while holding B. If I drag to the left, it will reduce the radius. If I drag to the right, it's going to increase the radius. I'll go ahead and let go of B. The other keyboard shortcut that's pretty universal is if you just left click and drag, by default this brush wants to add 100% influence. Now I can't actually add more influence because it's already there. You also can't add influence to vertices that weren't originally part of the selection when we created this cluster deformer. So when I try to paint down here, nothing happens. Now, the keyboard shortcut to do the opposite or the inverse of my current brush. Right now, when I left click and drag by default, it's going to add 100% influence. If I hold the control key, it's going to do the inverse of that, and it's going to remove influence. So you can see as I hold control and drag over these vertices that are part of this cluster, it starts to remove that influence. The shift key. So if you hold shift, it will allow you to blend those weights. So I'm going to hold shift and maybe see if I can get a smoother transition between those points there. So again, I'm just holding shift. And left clicking and dragging to smooth this out. And if we go back into object mode and take a look, we can still grab the C and move it around. So if we get back to the sphere there, it'll go more or less back into its original shape, or we can continue to pull it out, but it's going to have a softer sort of fall off there or a smoother transition. Again, we can also still play around with the envelope to animate between the default shape and the deformed shape. And again, because this is history based, if I were to grab my geometry in its current state and go up here to edit and delete by type history, it will delete the deformer and the geometry is going to maintain the shape, and there will be no way to get this back into its original state once we've deleted that history. So this is something else to keep in mind. Once we've rigged your character, we can't delete the history because the skinning is again history based, and once we delete that, it's going to detach your geometry from your rig. So that's a cluster node. Let's go ahead and delete that. Let's see, what else do we have here? The next thing we'll look at here are lattices. Now, there's a couple different uses for lattices. One, we could use lattices to quickly and more easily model or shape a dense geometry. So if we have a geometry with just tons and tons of vertices, it might be difficult to control or reshape those the topology of that geometry just because there are so many vertices. But we can use a lattice to help us do that a little more easily. We can also use the lattice to create more complex geometries fairly simply. So we can do something that would maybe be harder to do by hand. We could do it a lot quicker with a lattice. So let's take a look at those couple different options there. So I'm going to start by creating a sphere, and I'm going to add some subdivisions to it. So let's smooth this. And so you probably would never model a sphere with this amount of dense information, but again, there's just so many vertices, it would be really difficult to change the overall topology of this sphere. It's just too much to sort of maneuver around. So if I did want to change maybe the overall shape of this, I would use a deformer instead, or a lattice. So let me turn off that wireframe. Let's grab this object and go to Deform, and let's apply this lattice. Now, I'm going to open up the outliner here on the left-hand side. So the lattice you have here in the outliner, you have the FFD1 lattice and the FFD1 base. So if you ever want to select this, you could either click on the cage itself. So what it does is it creates this low-res cage that goes around your entire geometry. You can either click on that directly from here, or you can select it from the outliner. Sometimes it is easier to do from the outliner. So let's see here. If we take a look at the cage itself, if we right click and go to lattice point, you'll get the individual lattice points that we can start grabbing and moving. So again, if we wanted to change the overall shape of this topology a little quicker here, we could grab these vertices and pull them up. We can scale them out, do whatever it is we want to do with these. Let me reset my scale tool here. And so again, it's a lot easier to maybe change the overall topology of a dense geometry this way. This would be a little more difficult to do otherwise. Let's see what else. Let me undo that real quick. Let me select that lattice cage again. If you look over there in the shape inputs, so we have the FFD1 lattice shape with some division attributes. So you have S, T, and U, and this just dictates the number of edge loops you have going through your lattice, and it more or less controls the resolution of the lattice itself. By default, it's always set to a value of 2, 5, and 2, and so this number of 5 is what's creating these edge loops that go around this cage. If we come in and key that out to just 2, it'll remove those edges, and it's going to reduce the amount of vertice or lattice points that I have to control this shape. So if I go back here, I now just have the 4 corners, and I might be able to shape this up a little more quickly with less resolution. We could come back here and add more. So the S direction is going to add it going this way, around. Again, the T direction is going to go around horizontally, and then the U is going to go vertically, but from the front instead of the side. And so let's set all of these to 3. And again, this just dictates how this is going to deform our geometry. Oh, missed a point there. We can also use this to drive animation. So let me start from scratch here. Let's make a new sphere, and let's make a pipe. Alright, and so I want to make it look like it's squeezing through this pipe shape. So I'm going to grab the sphere. I'm going to come up here to Deform, and I'm going to add a lattice to it. I need all these lattice points here in the center, so I'm going to leave those alone. I'm going to right click and go to lattice point, and I'm going to grab all these lattice points just in the center here, and let's uniformly kind of scale them inwards until it looks like our sphere is being sucked through this pipe shape. And then this lattice shape is controlling the overall shape or deformation of our sphere. If we were to start pulling the sphere out of the lattice deformer, it will go back to its original state. So if I grab this and pull it up, you'll notice it'll eventually go back into a sphere. And so it does rely on that cage deformer again to create that shape. And so what we could do is take our sphere and let's key it up here, and then we'll go forward a few frames and pull this down, and then key that. And we could play this, and then it's going to look like this is being sucked through the pipe, and then it goes back to its original shape. So we can, again, use deformers in this way, or at least the lattice deformer, to drive animation. Let's stop that. Let's see. Again, we can use this for modeling complex objects that would either be really time-consuming or nearly impossible to do by hand. So let's take a look at something here. Let's make a plank. I'm gonna give it some height. I'm going to lower the depth here. So of our plank of wood. I'm going to give it a one subdivision there, and let's do one in height, like so. Make it just a little wider. And then I'm going to take this and delete its history real quick. I'm going to need some duplicates of this geometry, so I'm going to go up here to File, Edit, Duplicate Special, and click on the Options box. And let's reset the settings here. Now, I don't know really how far forward this needs to go in X. I know it needs to go forward in X. So I'm going to do some trial and error here until I get the distance I need here on the duplicate shapes. So here for Translate X, I'm going to try a total of 1 Maya unit positive in X, and I'll hit Apply. And so it looks like that's not far enough. Let me hit Control Z to undo. Let's try 1.5 and hit Apply. It's actually not bad. Let me undo that. And let's do 1.4 and hit Apply. And I think that's better. So I'm going to take this duplicate here and delete it. I'm going to grab the original. Now that I've got the distancing right, I'm going to increase the number of copies. So let's do 25 copies and hit duplicate or apply. I'm going to undo that. Let's do more. Let's do 40. All right. And let's hit close. So we're trying to model a fence, and what I would like to do is have a more complexity to this, maybe some variety in terms of the shape of the top of the fence. Now we could use a lattice deformer to help us control this, but in order for the lattice to work on multiple geometries, we're going to have to combine them as one first. So I'm going to grab all these geometries, and let's go up to the modeling submenu. I'm going to do a mesh combine. And then anytime we do a combine function or a separate function, we immediately want to go up here to edit, and let's do delete by type history, and it should clear out our outliner over there. It'll get rid of all those empty nodes. And then let's grab this geometry. Let's go to back to our rigging submenu. Let's go to deform, and let's do a lattice deformer. Now I need more lines going through, or edges going through the vertical axis, not the horizontal. So let's play around with the divisions here. Let's see, I think it's the S. Yeah, so we're going to add some more here in the S division. And then I'm going to take the T divisions down to just 3. So I get one going around the center there. And then this is where it becomes difficult maybe to select the lattice, because it's the same shape as our fence. So again, this is where I might come into the outliner here and select the lattice deformer itself. I'm going to right click and go to lattice point, and then we can start grabbing these lattice points. I'm going to do every other one here at the top and push those down. And so now we get this kind of zigzag shape in the top of our fence. So again, this is going to get us a much more complex shape with more or less little effort on our part. Again, if I were to try to do this by hand without the lattice deformer, it'd probably be really time consuming. We could even add some curvature to this. So if I were to, let's say, grab all of these lattice points here in the center, and then hit the B key for soft select, and then I'm going to hold B and middle mouse click and drag to increase the fall off. And then I could pull this out. We can add maybe a little bit of bend to our fence. Might want a little more fall off than that. Let's try something like this. There's another way we can control this. So again, I'm going to go back and select that FFD1 lattice here from the outliner. I'm going to go to the attribute editor, and we're going to click on that FFD1 tab. So it's called FFD. Usually we don't see it or called that way in Maya until you start getting under the hood or selecting these nodes. That name comes from 3ds Max. They usually call them FFD modifiers. But again, it's the same thing as a lattice. If we come in here under the FFD1 tab, though, there's this local option. And right now, that's what's causing the rigidity in our deformation here. So if I were to turn local off, we get more of a smooth transition between these lattice points. And then again, this will allow us to get maybe a different shape with our geometry. So if I go back to lattice point and start playing with these, I'm going to hit B to turn off soft select. And we can get kind of a wave pattern in our fence. So it's going to be, just a smoother transition. But again, something that would probably be difficult to do manually. And then again, if I wanted to finalize this and make it permanent, I would go up here to Edit, delete by type history. It'll remove the lattice cage or deformer, and now I've got my wavy fence. Let's take that and delete it. Let's see, what else do we have? Let's go back to Deform. Let's open up the nonlinear and start taking a look at these. So in here we have a variety of options. We have bend, flare, sine, squash, twist, and wave. And there's a lot of stuff we can do with these. We'll start here with the bend deformer. And so I'm going to need some geometry here. Let's create a cylinder. And let's increase the height. And then I'm going to need some geometry here. Let's add some more subdivisions here along this axis. Oh, not this one. In height. And then with our geometry selected, I'm going to add that bend deformer. Now if I go into X-ray mode, you can see the deformer itself. It's this long vertical line going throughout my cylinder. And again, this is history based. So if we were to grab the geometry and look over there in the inputs for our channel box, we should have a bend option. If you click on this, you're going to see a variety of settings in here. So we have envelope, curvature, low bound, and high bound. Now each of these nonlinear deformers, they're going to have different options depending on which one we applied. But some options in here you'll see commonly across all the deformers. Most of them are going to again have an envelope. Again, that's going to be the overall influence this deformer has over our geometry. Again, the default is 1, which is 100% influence. A value of 0 is no influence. Now with a bend deformer, the curvature, it is specific to this deformer. And so if I were to grab curvature and middle mouse click and drag here, it's going to start bending our geometry. So this will allow me to go positive or negative 180 degrees. And so I can bend it in either direction like so. And so let's bend it here. And then you have your low bound, high bound. Now these two are also fairly common in the other deformers, so we'll see these settings quite a bit with the other ones. But the low bound is going to control the amount of influence starting at the bottom of your deformer going in towards the center. So if I were to take this and increase it from -1 to 1, you'll notice it'll start to remove influence from the bottom half of this deformer. Let's put that back to its default of -1. Your high bound, it's the same. It's just on the opposite side of your geometry. So it's going to start from the top and it's going to go down to the center. Just like our other deformer there, or the lattice cage, you can animate your geometry along this curve. So if I push this down, it's going to align along with the shape of the curve itself. Let me undo that. Is there anything else with this one? I guess we could see the envelope. Let me take that high bound back up to its default. So again, the envelope just dictates the overall influence. So if I take the envelope from 1 down to 0, it'll eventually get rid of any influence this deformer has. And again, that's something we could key and animate. Let me go ahead and delete this, and let's look at maybe a practical way we could use this deformer for modeling. So I'm going to create a plane here. And let's see, let's increase its height and its width. I'm going to turn off the ground plane just so this is easier to see. And then I'm going to start adjusting the subdivisions here. And so we're going to make a tire pattern. We're going to start with the tread pattern first. So like I need one more there. Let's try that. So I'm going to select every other row of vertices here. And then we'll push these forward. I'm going to grab these faces here in the center. And let's extrude them. And then pretty similar to what we did with our fence, we're going to need to repeat this tread pattern. And so I'm going to use the duplicate special to do that. And again, it's a lot of trial and error until we find the right settings. So I'm going to go edit and reset. And all I really know is that it needs to go forward in X. So I'm going to try a value of 2, hit apply. And that's definitely not enough, so let's undo that. Let's try 5. And I hit apply. I'm going to turn on the wireframe mode real quick just so I can see this. That's still not enough, so let's undo that. Let's try 6. Not even close. Let's undo that. Let's try 8. It's getting closer. Let's see. If we really zoom in on that, it looks like it needs to go just slightly forward more. So let me undo that duplicate special, do a Control Z. Let's take this translate mount up to 8.1. So that's way too much. Let's try 0.02. And even that's too much. Let's try 0.01. And that's actually pretty good right there. So it looks like 8.01 is our magic number. Let's take that and delete it. Let's grab our single tread now and let's do 30 copies and hit apply. So we've got a strip of tread here. Now, in order again for our deformer to work on this, we need them to be one geometry. So I'm going to marquee drag and select all of these. We'll go up to the modeling submenu and go to mesh, combine. And then again, we've done a combine option or function. Let's go to edit, delete by type, history. And then they look like they're one solid piece, but if I were to come in here and right click and go to vertex mode and tap once on this vertice and move it, you can see they're still separate geometries. And so what we need to do is merge those vertices. So I'm going to marquee drag and grab all the vertices on this. I'm going to go up to edit mesh. I'm going to go down to merge and click on the options box. And I just want to make sure this is set to something low. And basically what this is saying is whatever components I currently have selected, if they are this number of Maya units away from one another, they're going to merge into a single component. So I want this to be relatively low. I'm going to do 0.001 and hit merge. And then that should have merged all of those vertices that are lying directly on top of one another. We could test this out. So if I grab this vertice now and move it, it should move all together. All right, so that's good. Let's go back to object mode. Let's grab our tread now, and now let's apply a bend deformer. Now, the deformer itself, it's still going vertically, so it's going in the wrong direction. If I were to go into its input setting here and increase the curvature, it's not really bending in the way that I would expect it to, at least not for what I need. So let me undo that. I'm going to grab that bend deformer and I'm going to rotate it 90 degrees in Z here. And then let's go into its input and add curvature. And it looks like we're going to have to take this negatively. And now it's going to start rounding this out for a rounded tire tread. And then by default, it won't let you go beyond 180 or below negative 180. But we can, if we needed to, we could come in and maybe key in this value. So if we needed to go lower, let's maybe try negative 181 and hit enter. And we're just going to, again, this is trial and error, kind of similar to our duplicate special function. I just need to lower this until it gets us right on top of that edge. That's really close. Let's see. Just a little bit of overlap, so it looks like I could maybe have a little bit of less value here. I'm going to do negative 0.05. Oh, that's not. Let's do negative 0.09. And that's pretty close. All right. So if we want this to maintain its shape, so again, it is relying on the deformer itself. So if we pull this out, you can see the tread is going to go around the deformer. Let's undo that. Let's grab the geometry and go to Edit, Delete by Type, History. It'll delete the deformer. Now again, where we have that seam down here, those vertices aren't attached. So let's go back to vertex mode. Let's grab all these vertices and let's go to Edit, Mesh, Merge to merge those. And then we could continue to model this up if we wanted to. I'm not going to spend a bunch of time doing this, but we can maybe double click on this edge and this edge, and we can come in and extrude it. So you'd spend a little more time making it look nice. But again, complex geometry that would be relatively difficult to do manually or by hand without using a deformer to get this shape. So again, another useful use for a deformer. Let me delete that out. Let's start looking at these other ones now. So I'm going to do the flare. Let's get our ground plane going again, and let's get our camera oriented to default. Let's open up, or let's create a new cylinder. Let's open up its settings and let's increase its height. And let's add some divisions here in the height. I'm going to grab this and let's apply a flare. Now the flare looks pretty similar to the bend, so you're going to have this vertical line going through your geometry. This one is a little different in that it has these circle curves at the top and bottom of your geometry. If we go in here into the flare input settings, again you'll have envelope at the top and the low bound, high bound at the bottom. Again, those have the same functionality as the other deformers. This one does have some unique settings though, so it has start flare for X and Z axis, as in flare for X and Z, and then curve. So with the start flare, we can do this in one axis at a time. And what it's going to do is expand or decrease the flare. So if I increase this X for the start, it's actually going to be at the bottom of my geometry, but it's going to expand outwards in that axis. If I do the start flare Z, it's going to go in the Z axis. And so, you know, we can scale these non-uniformly or uniformly depending on what shape we're after. And flare's the same, it just does it from the opposite end. So we can do it from the top here. The curvature. So this is going to sort of bloat your geometry in or out from the center of your the deformer. And again, the low bound, high bound. So it just dictates how this is influencing either from the bottom or the top. I think I just inadvertently made a wine glass. So that's the flare. Let's undo this. And I'm going to delete the deformer here. Let's look at sine. So with this one, I might want more geometry in the height here. And let's grab this and add a sine deformer to it. Again, it's going to look pretty similar to the other two deformers where we have this vertical line going through. But if we go into the sine options and take a look, so this one, it's going to have amplitude, wavelength, offset, and drop off. The amplitude is going to be the extreme in the wavelengths. So if I were to increase this, you can see it starts to really push that geometry out to an extreme. And we probably wouldn't want to go that far. The wavelength dictates how many actual waves are in this. The lower you go with this, the lower or the more waves you have, the higher you have set this, the less waves you have. So if I were to take wavelength and reduce it, I'm going to start getting a lot more waves throughout this geometry. And so I'd probably use a combination of the amplitude and the wavelength here to get the desired effect that I'm after. Offset, this is something we could use to animate this deformer. So we could get why isn't this working? Let's see. There it goes. And so I could key this. I'm going to key the offset at -10 there. Let's go forward 120 frames and put that up at +10 and key select that. And so we can have it animate our sine deformer here. Let's go back. Let's see, what other settings do we have in here? Drop off just drops the effect off either from the top or from the top and bottom. So here at a +1, it's going to remove the influence or have a drop off from the poles. If you go negatively with this, it actually does it from the center instead. So you can see it's kind of reducing the amount of influence there from the center when this drop off is negative. Let's see, what else do we have? Let's delete that deformer there. Let's add a squash deformer. Again, visually it looks pretty similar. If we come in here, you have factor, expand, max or maximum expand position, start smoothness, end smoothness, and then of course the low bound, high bound. So the factor, let's go ahead and play with that. So the factor is going to increase or decrease the amount of stretch or squash happening in your geometry. So this is something we can animate to get this kind of stretchy squash effect. The expansion is going to dictate the expansion here from the center of your object. So let's go play with that. So if I grab it and increase it, it's going to expand outwards. So we can really push or exaggerate the squash. If we go negative with this, actually it goes to 0 and just eliminates the expansion altogether. The max expansion position just dictates the position at which the expansion is happening. So if I middle mouse click and drag this, we can move it from the center up or down. And then the smart smoothness and end smoothness just dictates how the fall off happens or how smoothly it transitions from either the bottom of your geometry or in this case the end smoothness would be from the top. And then again you have the low bound, high bound, which does the same thing as all these other deformers. But that is the squash. Let's go ahead and delete that. Oh, let's just delete the deformer instead of the geometry. Actually, yeah, let's use this geometry, but let's change its settings. So the twist deformer, it's going to allow us to twist our geometry. Now this might be really useful for, again, creating more complex geometry that would be really difficult to do by hand. So I'm going to start by reducing the amount of geometry I have on this. Do something like that. I'm going to go to the top view, and I'm going to grab this geometry and right click. We'll go to face mode, and I'm going to marquee drag over the sides like this from the top view. What that's going to do is it's going to select all those sides going down there, but it's also going to select the top and bottom faces. But let's go do that real quick from the top view, and I'm going to go every other face here like this. And then to deselect all these faces at the poles, I'm going to hold Control and marquee drag and deselect those. And then what I should be left with is those series of faces there, those rows of faces going every other. And then with those selected, I'm going to go into the modeling toolkit and let's extrude these. And pull them out like so. And then let's grab this shape and I'm going to turn on the wireframe and then I'm going to add the twist deformer here. And let's go into the twist deformers option. So I'm going to grab the geometry, open up the twist, and this has a starting angle, end angle, low bound, and high bound. So with this one, our primary controls are coming from the start angle and end angle, and really this just dictates where the twisting is happening from. So if we do the start angle, it's going to start twisting from the bottom, and we can do something like this. The end angle, if we twist this in the same direction, it will get us back to our default, so we would actually want to rotate this in the opposite direction to our start angle. But we could use this to get fairly complex geometry. So if we wanted to model something like a drill bit, a screw, or something like that, we could use the twist deformer to get that type of functionality out of this. Yeah, that's the twist deformer. Let's grab that and delete it. Let's see, the last one we'll look at here is the wave. Now this one's going to be a little easier to see on a flat plane. And I'm going to increase its width and height, and then let's give it a bunch of subdivisions here. Might even subdivide this one more time. Let's go to smooth. I'm going to turn off the grid so this is easier to see. I'll select the ground plane and let's add the wave to it. Now the wave is represented by this giant circle, and if we grab its input over here, this has amplitude, wavelength, offset, drop-off position, minimum radius, and maximum radius. So the amplitude, kind of similar to the sine deformer, just dictates the extreme at which this is deforming our object. So if I were to increase this, I might have too much geometry. Let me see what happens when yeah, I guess I can do it manually by hand instead of scrubbing through. Yeah, it does not want me to use the viewport anymore to do that. Let's try that again. Okay, there we go. So yeah, the higher you increase your amplitude, again, the more extreme the effect or the deformation is going to be. So this is something we'd probably want to be a little more subtle with. Wavelength is going to dictate the number of ripples that we have. And again, just like sine, if we decrease this value, we're going to get more waves. If we increase this, we'll have less waves. And so we're going to play around with the wavelength here. We'll give it quite a few waves there, and then adjust the amplitude to make it a little lower. And now it's going to look like a ripple of water on this geometry. Let's go back here. Offset. So the offset, this is something else we can use in terms of animation. So let me key this at, let's put it at 0 and key it here at frame 1. Let's go here to the end, frame 120, and let's maybe do a value of 50. Key select that. And then if we hit play, it's going to animate our ripple effect. That's probably a little fast, so we would want to adjust accordingly to our timing, but let me delete this and put the offset back to 0. Drop off. Let's see here. So depending on what direction you come in, the drop off is going to create sort of a fall off. If you go positive with the drop off, it's going to create a drop off from the outer edge here, so this circle shape. The fall off is going to happen from this edge going inwards, so it's going to create more of a subtle transition into the ripple effect. If we go negative with this, it's going to do the same thing, but it's going to do it from the center as opposed to the outer edge. So if I take that negative, we get a little bit of fall off here from the center. Let me put that back to 0. Drop off position is just, it'll allow us to control where that drop off is happening. But if we're not using it, we're not going to see an effect. The minimum radius and maximum radius. So if we were to play with the minimum radius, you can see it starts from the center and it defaults at a value of 0. Once I start taking this up to a value of 1, it's eliminating the effect from the center going outwards until it gets rid of the effect altogether. Let's take that back to 0. The maximum radius does the same thing, but it does it from the outer ring instead of the center. So its default is 1, but if I start taking this to 0, you can see again it's going to reduce the scale of our ring, and again reduce the influence starting from that ring inwards. We could jack that way out here like this. And then if we were to take this, I think we should be able to scale this up. And we're going to get a lot more ripples based on the scale of that deformer. You can stack these two. So if I were to grab this geometry and add another wave to it, we can grab these deformers and move them. So I'm going to move this one maybe off to the side here. And let's go into its settings and let's lower its amplitude. Let's decrease the wavelength here to get some ripples. Let's maybe decrease the amplitude some more just to make that a little more subtle. And then we can play with that max radius and have that kind of overlap the ripples we already have, just to break the surface up even more. So that's the wave. Let me go ahead and grab all that and delete it. Let's actually do a Control-N, do scene. And I think that's really it for our deformers. Let me see. Yeah. So I'm going to stop here, and in the next video we will start looking at joints and binding them to geometry.